perspective, and how cloud technologies have helped or are helping us to navigate through these challenges, and how we are trying to leverage the latest AI technologies to kind of benefit the organization and help the people doing the real job on the field. Having said that, I'm taking Oracle Cloud Fusion as it is on our landscape. But yeah, I mean, the concepts and uh, it is same for any application suite that is available in the market in the supply chain collaboration area. So just because we are on the Fusion, I mean Oracle Cloud, so I'm taking this example and running through these details. But yeah, I mean,
Harry, just 1 second. Sorry for interrupting you. Are you showing a PowerPoint presentation? Because we don't see that.
I am actually sharing.
Yeah. No, if we can see your screen, but we don't see the PowerPoint.
Oh, sorry. Why? Let me stop sharing and start sharing one more
Yeah,
time.
do it again there. Yeah.
Yeah, we were seeing the StreamYard screen.
Yeah. So try it there again now.
Okay.
Good evening, Stephen.
Yeah, good evening. Good evening, everyone.
Hey.
Good evening.
How about now, Frank? Is it the same?
No, we can't see your screen.
No.
Oops. Okay.
So when you go share screen, share entire screen.
Yeah,
and then click on the panel on the left then.
Okay. I think I did that. Let me try one more time. I stopped and
Okay,
I'm
1 second now. Right, we can see. Yeah, we can see it now. Yeah.
Yeah, good.
Yeah.
Okay, perfect. So Oracle Cloud Fusion, it's a comprehensive suite. What we have on our landscape, it's a cloud-based enterprise application designed to streamline and integrate organizational processes across various supply chain streams, including procurement, logistics, planning, and order management. The big advantage with these cloud solutions, what we have noticed coming from a on-premise environment, is like they deliver a unified data model and real-time visibility, and also the platform's modular architecture. They allow progressive adoption, and also it comes with all the latest and greatest technologies available very fast, rather than the on-premise, which needs major upgrades every time when there's a new technology innovation happening. We are always technology ready, from a cloud perspective when we are on the cloud applications.
Ari, we're seeing the PowerPoint presentation mode, not the full screen. If you click on the display settings in the upper, and then just swap monitors.
But that one is actually grayed out for me.
Okay.
Let me see, maybe.
You can probably set it up.
Are you using like external screen?
No, this just my on the laptop. I didn't even extend it to my monitors because I know that's causing some problems. Okay.
Maybe probably just stop and then stop the slide and then make it as presentation mode.
Okay.
Yeah, in the slideshow menu, when you're not presenting, you should be able to tell it to not use presenter view.
Yeah, because we see.
Or yeah, try hide presenter view, see if that works.
Okay.
Yeah.
There, perfect.
Is that good now?
Yeah.
Perfect. Okay.
Sorry for interrupting.
Okay. So why the transformation? What were the challenges that required a transformation of our supply chain? So we deal with thousands of suppliers onboarding and managing, collaborating on a monthly basis, and it required a lot of efforts from the internal teams, the teams managing the suppliers, monitoring, managing, collaborating. And management's perspective is we need to make suppliers as part of this collaboration, not just uh, the end users, kind of like just provide documentation and then wait for uh, our company to come back. So that's the whole objective, to bring them into the collaboration suite. And also, whenever we try to onboard a supplier, it is taking significant amount of time and delays because of the manual paperwork submissions, back and forth phone calls, and also when we started this supply chain, uh, you know, cloud initiative, those are some of the crucial objectives, to cut down these overheads, to cut down these delays in the onboarding, to cut down the lot of paperwork. So this has helped us significantly in the transformation process. And also, especially in the areas of suppliers, any changes to suppliers are audit attractive. Like, auditors have a lot of questions around these changes. And when we were on the manual or paperwork plus legacy ERP systems, so you do have the changes and you try to maintain all the documentation, but it is very challenging when the auditors ask a lot of questions on how, who did, who approved, and all. So that's where the workflows come into picture. When some auditors raise the questions, you have every change audited, every change audit completed in the system. It is easy to answer audit questions. And also scalability, with all these new technologies like the AI and everything, and so many technologies, latest technologies coming up fast. So our environment needs to be ready for embracing these latest technologies. So we went with the cloud fusion landscape there. And what was from a enterprise side, enterprise objectives, some of the enterprise objectives are not just on the supply or collaboration side. They were also looking for an integration within various supply chain functions. Like, earlier, this is not just a supplier tool, okay, where you manage suppliers and then. So this is more collaborative, integrated, along with a lot of procurement activities, contracts, agreements, pricing, inventory, order management, logistics, and all, bringing into one ecosystem basically. And on top of that, now data is crucial for everything. Okay, we're depending a lot on the external tools for our data analysis, but that requires a lot of data integration happening between various things. But now people want to see that impact straight away, and that's where even the embedded intelligence and analytics helped a lot when we moved into this space. And also, these systems are like, not just a device dependent, like, the same system, same application, you can see it on a mobile without any changes, without any on a tablet. It is ready to be fit onto a Mac, any monitor size. So these are all the new application features that was helping a lot with the mobility as well. So now start with the supplier qualification, one of the prime objectives of the whole program. So as we onboard and manage hundreds of suppliers every month, so some of those activities are creating new suppliers, collaborating with the existing suppliers, getting them registered, and maintaining their profiles by themselves. If there is any change to their bank account, let them go ahead instead of sending a large paperwork and then wait for our finance team to review it, get it approved, and again it has to be updated. Call the supplier, inform them that it has been updated, and send it. So avoid all that. Like, now supplier can go into their profile, update. It goes through a series of workflow approvals, and then it's updated in the system uh, within very short span of time, instead of hours and sometimes days of activity. We go back to the architecture diagram in our landscape, where Oracle Cloud SQM is our supplier collaboration suite, and Oracle JD Edwards is our end ERP system, our core ERP system. So while onboarding a supplier, there are many pieces, many components that come into play. Okay, some of the crucial points we were manually having challenges with manual checks and balances is uh, checking their tax identification numbers. Okay, supplier submits a bunch of documents and their W-9s and um, some insurance documents. It's a big packet that comes through, and going through that documents, because they're in different formats, they're in different years, so it was very challenging for the teams to understand that and go through the details and approve. Now, when they submit this through online, we have APIs developed and integrated with various third-party systems. Like TinCheck is a IRS tax identification system. So as and when the supplier submits, even before it is approved, a back-end process actually does the TinCheck with the API, and then it comes up with a summary even before it goes to the first level of approval, saying that, hey, the TinCheck is successful, the details submitted by the supplier is matching with the IRS records. Same like Office of Foreign Assets Controller, OFAC. So it's a very regulated industry that you can't do business with every vendor across globe, and also you need to make sure that you are not doing business with sanctioned nations or some organizations. So if by mistake you miss that line, you cross that line, and you do any kind of business with these parties, then uh, you are penalized heavily. So now OFAC check is also through an API. I mean, even before the first level of approver looks at the data, it clearly explains, okay, if there are any of the supplier listed on OFAC, it calls out all those details like, hey, this supplier is listed as part of a nation that's on sanction list, or an organization. So just stay away from doing this business, right? Same with some suppliers who do business with us mandatorily requires a lot of insurance and compliance documentation. They need to go through that before they enter onto our manufacturing sites. So they submit this insurance and compliance documentation, but again, going through that pages and pages of documentation is taking time. Now with the AI embedded into that, it goes through the documentation and comes up with a clear summary with what we really want to see out of that. Hey, this vendor is certified to perform like blasting operations, or this vendor is hauler is certified to get into these quarries or mines, and these are the insurance details, like they are going to be valid until these dates. Same with bank accounts. Okay, bank accounts are very crucial, that when the supplier submits documentation, some of the times their names won't match with the accounts are not existing. So now online bank account validation, they submit the details, it's already tightly integrated, and it looks for the details on one of the bank APIs, and it does the checks and balances behind the screen globally. So yeah, these are all the new features that helped our business partners to perform their day-to-day activities more efficiently and focus on critical activities rather than focusing on more documentation review jobs rather. And this is a flow or process flow diagram as part of any new supplier we onboard, how the registration is submitted by the requester, and then it goes through various and who receives the notifications for approvals, and who approves it, and if it is a certain supplier, how many levels of approvers has to approve, or if it is a hauler or a supplier performing on-site services, he needs to be approved by compliance team. They need to review this compliance documentation, whether it is certificate of insurance or whatever, all those documentation, and all the bank account and ACH information needs to be reviewed and approved by the finance team or the accounting team or AP team. So all these are configured such a way that you don't have to kind of monitor like whether this has been approved by all these parties or not. So at the end, the supplier is finally approved once all the parties does their job. Like you go review in your space whether all the information is correct. There are a lot of automations behind the screen helping you to summarize the supplier profile, to summarize what they do, to summarize what their background checks are and all. So finally, all these parties, once they approve, the supplier is finally integrated into the core ERP system and ready for doing business with them. And these are the new AI agents and Oracle Cloud ecosystem holding. I mean, there are so many coming up every day as part of the new releases. We are still in the process of evaluating what helps us instead of trying to implement all the AI agents that are available on the cloud space today. We are going with cautiously embracing or cautiously, going live with those agents that are really helping us. For example, uh, the supplier request summary is very helpful. You don't have to go through all the details one by one field. First level approver, before he approves, he has a summary now. Okay, this supplier is going to provide these parts and services, this services in these areas. Everything is summarized for him. So that helps him in quickly taking a decision and approving it on the mobile. Like, he doesn't have to go into the system, navigate through hundreds of screens, finally approving. Now everything is summarized and upfront. You can just hit a button on your email that completes approval process from your end. So that's the whole program was all about. We deal with close to 18,000 suppliers today, and it was even more. But when we went live, we kind of almost deduped 20 to 30% of the suppliers based on all these checks and balances, like, what the business they are doing, what are their tax IDs, and are there really duplicates in the legacy systems and all that. So now we are in a more stable state, and we are seeing the benefits of all the implementation and the efforts we did as part of this cloud initiative. I think that's pretty much from my side. Frank, any questions? I'd be happy to answer.
Thanks, Harry. Great presentation. Very clear. Very good.
Thank you.
And great to see all the new cloud technologies in there, and these expanding big time, isn't it? Anybody, any questions for Harry? No, you're all good, Harry. And we have the LinkedIn. If anybody else has any questions for Harry, you can stick it into the LinkedIn there, or our comments.
Thank you.
Okay. So over to you. Owazen.
Good evening, everyone.
Yeah,
Um,
yeah.
my name is Oluwaseun Deborah Debayo. You can call me Deborah. So today I want to speak and we discuss about what really happens when we call an Azure Open API and the common mistakes we need to avoid. So this is just like a practical breakdown for we trainers, architects, builders, and I'm gonna be using a system I'm currently working on. I call it NOSA as a case study. So I'm just trying to play around some of these tools to bring out something and like an AI assistant e-learning environment. So I'm going to be using that as a case study. So currently I'm sharing my slide. Is that what we can see on the screen?
We can't see it yet. Can you just try and share it again?
Okay, so I'm just going to do that. Okay, share screen.
If you uploaded them, they will show up under slides and PDFs.
We have it there now.
Perfect.
Yep, there we go. We can
Yeah.
see yours.
So can you all right, okay, very well. All right. So basically most people think calling the Azure Open AI is just about sending prompts and getting a response, but in reality, based on my experience, because while working on that system there were a lot of back and forth errors, issues, failures that I had to troubleshoot, and it actually gets me sunk into the process to have more deep dive understanding. So it's a full cloud workflow involving the front end, the back end, the security layers, and the Azure enterprise grade as an entire safety pipeline. So it is beyond just a call and response relationship. And when you use an Azure Open AI, your requests doesn't just go straight to the AI model. So we would think of the Azure Open AI like when you're trying to send a letter, like a mail, we're trying to send it through a very secure and well organized postal system. So that is just what the Azure Open AI operation flow looks like. Before the AI would give you an answer when you send a request, it would first have to pass through several protective and management steps inside the Microsoft ecosystem itself. And these steps would make sure that everything within the contents of the mail you enveloped is safe, it is controlled by the organization policies and regulations, and everything is working properly. I have okay, so I have just like a pictorial explanation here. So the first one, which is the one on the left, kind of relates with the layman understanding. So where we have the networking stage representing how letters are being delivered. So basically, it's just talking about how Azure AI handles our request, or I would say how the delivery man handles our email. So we'll think of it in that phase for us to grasp, some deep understanding about it. So the first phase, when we have the request traveling through the internet to reach Azure. So we look at it like a letter moving through the different postal routes. And then the second phase here, it checks for security. This is where the system would check that the request which we have made is safe, it is allowed by the organization policy, and it is coming from the right person. So in this phase, we can look at the confidentiality, the integrity of that mail that we are trying to communicate across. Then the next phase is the governance stage, where it follows the rule. It ensures that the process of the request and granting the request actually follows the company policies, the privacy rules, and if there are any restrictions that are set by the organization. After this phase, it moves on to sending it to the right department. That is the orchestration level. Here, Azure will decide which AI model or service is best suited to handle our requests. And then it moves on to the compute stage, where it actually does the actual work. And this is where the AI model would finally process the request and generate a response. So at the safety level, it would also do like a double check of the response to be sure that it has actually provided the right response to the question. Most often times when we query any of those AI tools, maybe Copilot or Chat GPT, sometimes it gives us some weird response. And then we have to reprompt, we have to requery it, maybe by making sure that the keywords that really matter to our request are included in the request. Then it regenerates the response. So at the safety phase here, it will have to do a double check to be sure that, okay, our response or the response it has provided is actually what matches the request we made. Then finally, it delivers the final message only after passing all through those layers. And just as it is in a plain English, we have it in the technical concept on the right, where we have the architectural concept, which talks about the first stage of making the request. So the request can actually be made by a developer or through an application. So looking at the first architecture, which is just the non-technical, put it that way, or from the managerial aspect, we would agree that there is a lot that goes on in the internal system in the background when we call an Azure OpenAI. So it is not just a click and run operation. So I'll be explaining in the technical domain using the right diagram I have on the screen, which has the architecture concept and explains through the 7 layers as well: the developer application, the Azure OpenAI API, the Azure cloud infrastructure, the OpenAI LLM, the response processing, and finally the client receives AI response. So how does this work? We all are familiar with, querying an environment using any kind of application. So the application in this phase could be, it could be a web app, it could be a mobile app, it could even be the Chat GPT platform itself. Any application, any interface that would accept a user prompt, and these are applications or environments that we can use to make this request. So the request would usually contain prompts. That is, when I say prompt, it's just technical, the sentence or your question or what you want to query the system about. And it would also contain the API credentials, and then it will contain some parameters like the response length or temperature. This is just like your structure, your prompt structure. So I would say at the application layer, you configure or design or construct your prompt structure, which would then be received by the Azure OpenAI. That is the second phase. At the Azure OpenAI, what happens there? Your request is received from the application layer. Then the Azure OpenAI would act as a gateway between your application and the AI model. So at this stage, you can define what model you want to work with. If it's going to be the GPT 4.0 or 5.2 charts, there are a lot of models in the Foundry that you can actually choose. So the Azure OpenAI AI is bridging, standing as, it's representing a communication gateway between your application layer and that model. And this layer would undo the authentication, which is actually the checking for safety, the security layer in the non-technical diagram that we have on the left. So here is going to check out for the API authentication, is going to check for the request validation, and it is going to check for communication with the Azure services. So practically, everything that has to do with security check happens at the OpenAI phase. Then next, the request is processed within the Azure Secure Cloud environment. What happens at this phase? Azure here would provide the networking information. It will provide the security controls. It will provide scalable computing resources, and then it will provide the monitoring and logging information. Your Azure cloud infrastructure here, some organizations work with some custom cloud infrastructure, but still all embedded within the Azure cloud services. At this stage, we have everything that has to do with looking towards the governance. If this request is actually following the proper rules, the proper policies, the proper security controls that has been laid down by the organization. Then next, it moves on to processing the language models. And here the request to be forwarded to the AI models, such as your GPT models or whatever models you want to work with in this case. Then the model will process the prompt, which has been collected from the application layer, And then at this stage, it will be working with the machine learning algorithm and generate a response. Then that moves on to the sixth layer, which is the response processing layer. And at this point here, before it sends back the response to the user who made the prompt, it has to do a formatting, does a double check to be sure that the response is actually correct, it is error free, and it is also it doesn't contain any it doesn't contain words that are actually, for example, because with the Azure Open AI, you can actually check for some terminal words like offensive words. So it's going to do all of this check to be sure that the response is given out. It's a correct response, an error-free response, and a right response. And then finally, it returns that response to the user who prompts the request from the application layer. So in a non-technical view and from a technical view, this is what happens when an Azure Open AI is called. So it's pretty much a journey, but this is not something that is exposed to the physical eye or the front end or the end users. All they know is, they just prompt their web. Maybe they want to go to www.azure.com, and then in seconds, it returns their request to them. But in the background, all of this phases, all of these layers has been passed through. So what are the key components of Azure Open AI? We have just two basic components. We have the AI models, we have the GPT models. The AI models could be the GPT, the embedding models, and models that could actually incorporate text messages or images. We call them multimodal. And the second component is the API access, which actually helps communications with this application using the REST APIs. And an example of that is what I have here. So this is an example of what our post request looks like when a developer wants to interact with the application using the REST APIs. So these are just the basic two components of the Azure API, the Azure Open API, the AI models, and the API access. Then talking about security and governance, Azure Open AI integrates with the Azure Entra or the Microsoft Entra ID. It integrates with the role-based access control, and it also integrates with private networking. It integrates with compliance controls, and this is the reason why at the appropriate layer of its operation flow, it's able to check if the request that has been made at the application layer actually follows the security controls, the policies of that organization. It does a double check and also check if the person who has made the request has the right permission to access such information before it returns the response. Also, one can also detect harmful content, like I mentioned earlier, using the Azure Open AI. You can detect offensive text and policy violations with the Azure Open AI. So this is also an example of the end-to-end flow, which I explained earlier, right from the client application, which could be the app, the web, the chatbot, or any other interface that an end user can actually prompt with. Then up down to the client's, the phase where the client receives the AI response. So I'm going to move on to the next. And here, I'll be mapping this architecture with the AI assistants I'm currently working on. So so far so good on the AI assistants. I've actually worked with a couple of tools. I've worked with a Foundry. I've worked with VS Code. I've worked with the Azure Open AI itself. Uh, I've worked with GitHub, and then and I've also worked with the Docker. So these are a few things that I'm able to pick up, because at a point I think that was when I was trying to launch the back end. Let me see if I can pull up the okay. I have the application on the screen. Is that what you can see?
Yeah, we can see it's the Novartrax Cyber Skills Assistant.
Okay, yeah, that's good. All right. So basically with this with this solution, I quite learned a whole lot, because this is like the first solution I'm going to be building, having learned some skills. And just like I said earlier, it's easier for me to put in hello, and I hit the send button, and it returns a welcome message for me, which is what I've actually configured it to be in the Azure Foundry while I was actually configuring the agent. Now, between the 2-3 seconds my hello was received and I get the response, all of the 7 layers has been passed through. All of those checks has been done before I was able to get the response. So this is a system that would be helping beginners, practically those who are just coming, transiting into cyber environments. They want to learn more about cyber security. They want to learn more about network security, cloud security, IAM, and more. And while learning, they also want to have like an instructor led a real time experience. And that's the reason why this chatbot is here. I know that there are a lot of similar solutions that are already existing, but one thing I used to tell myself is it doesn't matter how many of it is existing. When I'm working on when I'm designing or building my solution, I'm going to make it as unique as I can, and having that experience is also a unique experience for me. So I don't actually believe in, oh, what you are doing, someone is doing it already, or it is existing already, then because of that, maybe I might feel like, oh, I don't want to work on this thing again, or I'm not going to be doing it again. No, I actually want to push and see how far I can go with it. So basically for this, I use the HTML, CSS, the JavaScript, and I used Python in designing the back end. And those are basically what I used while making up the solution. And the chat interface, which we can see on the screen here, is created with those tools that I mentioned. So it's just like having a flow. Let me see if I can pull up this. Okay. So how the chat interface works, we have the user. The user would prompt the chat environment, and then all of the 7 layers, the prompt goes through all of the 7 layers and returns the response. So these are the tools that I worked with the web interface, which is the front interface. I worked with the HTML, the CSS, and JavaScript. Then for the backend, I worked with Python, and I installed the Docker file. And also I have my Python file, HTML, the JS in the Docker container. Then I use the GPT 5.2 model to as my model. So I will take us through the Azure Foundry environment just to see what so this is what my Foundry looks like. So I named my agents CyberSec GPT-5 2 chat, and so that's just pretty much what I did here. I have the Azure Open AI endpoint key, the API key, which I actually embedded in the .env file on my Visual Code Studio. And I was able to create some resources, the web app, the insights, which would monitor the application operations and also my container. And so right from here, although this is still a work in process, but this is just what I've done for now, and there are still lots to be done on this solution as I progress. So currently for now, I launched with the Azure URL, and right from here, visiting the site, I have access to this. So what I learned in this is calling an Azure Open AI is just beyond, a call and response thing. It is a whole lot of process that goes in the background. And what are the five basic five common mistakes that we need to avoid, that I did not avoid initially, and but I'm thankful to those mistakes, because when I ran into them with troubleshooting back and forth, I was able to learn more beyond what I imagined. I'm trying to bring up my okay. So one of the mistakes is calling an Azure Open AI directly from the front end. So this is one big mistake that we can make. I'm not talking about the experts now, but for those who are just coming into the AI environment, because the truth is, right now we have the artificial intelligence all over. There are a lot of expertise, a lot of specialists that would want to learn more about AI, start building solutions with AI. And of course, it's going to be a new domain, a new environment for them as well. So the reason why this is dangerous is because it exposes the API key and the Azure Open AI directly from the front end. It is also not it is not a security controlled practice, and it also allows users to bypass any safety rules that might have been incorporated, and it breaks the entire system architecture. So when we call, or we try to call, Azure Open AI directly from the front end, it is a dangerous practice which should be avoided. Another mistake is sending unstructured or messy prompts. Just like I mentioned earlier, I've seen a lot of people, that would always reach out to me that, okay, they are trying to use the chat GPT to do some research or to find out about some things, but it is not returning the right response to them, and they are confused. And then I discovered that most often times they really do not have the right or the proper structure to prompt this environment, because it's a tool, it is not human, so it would only work in the direction you want it to work. And so that's the reason why it is also important to ensure that when we are prompting at the application layer, we ensure that we have a structured prompt. Now, our structured prompts will define the keywords, the contents of what we want the Azure Open AI to return to us. If there is going to be paragraphs, we just have to make sure that our prompts are very well clear enough. Like, for example, now I might prompt and ask that okay, could you please guide me on how to install the .NET application, with that, it knows that, okay, it is going to give me a step-by-step guide starting from the beginning to the end. And sometimes you can also prompt it to let it know our level of experience with what we are trying to learn about or query. So basically, that is one of the solution the system I'm working on will be providing, because it's going to be a module structured learning environment where learners would have access to different modules for different courses, and there are assessments for every modules, and they can also have a real-time prompt. Unlike some other learning environments, maybe it could be a recorded session, or maybe some mostly recorded sessions, and even on YouTube sometimes, when some of us are taking some learning courses, some videos on YouTube, we might run into confusion at a point, and then we pause the video, we reverse, we watch all over again. We may not really catch what the instructor is trying to point out. And at that point, we pause the video and open another browser. We tend to put in our concern into the search engine that, okay, could you explain what this instructor is trying to teach here? Now, in that scenario, there is a possibility of the search engine not to return the expected response we want, because the search engine we are using does not have a direct visibility into that learning environment. So Novetrax has come to bridge that gap. It is an assistance that is embedded into the learning environment. So it has access into all the learning modules, and it is easier for it to connect to any learning module you want to prompt a question on, and it will return the right response. So here, sending a structured prompt is also a good practice. So we should avoid unstructured prompts when working with the Azure OpenAI. Another error we should avoid is not handling errors gracefully. For example, when we have error connecting to backend is one of the repetitive errors I experience while working on this system. And then I would discover that, oh, I didn't start the backend server. Then I have to go back to my Visual Studio Code. I'll restart the backend server, refresh it, and then go back to my fast API, which I'm using to test the front end, and it connects. And sometimes it could be an issue with my API key, because it actually took me a couple of days before I could figure out the right API key to use to work with. And in that couple of days, it was really a whole lot. But I'm happy I went through all of those times, because it's built me, and I'm able to figure out a lot of solutions. So there could be different causes to have the error connecting to backend error. One of the cause could be the backend not deployed or turned off. That was the case in my own. And another could be a wrong API URL. I also experienced that. It could be the cause issue or container sleeping. So when I installed my Docker, there were days that it was already shut down. The engine was shut down. So I had to go restart it for me to have a successful backend activation. So here we have to be sure that the backend to the Azure Container App is properly deployed and it is always running. What other mistakes should we avoid? Not using Azure Key Vault for secrets. So I also made this mistake because initially I had all my secrets. I had my API key in my .env file on the Visual Studio, and I pushed it to GitHub. So at the point I had an issue, I had an error that there are sensitive information there and I cannot push them to a public environment, which is GitHub, because my GitHub was a public repository. So I had to use the git ignore to make sure that the .env file is is taken off from the information that will be pushed to GitHub. And only at that time, I was able to have a successful push and pull and syncing. So hard coding API keys is a major security risk, and the architecture already supports key vaults. In our Azure environment, we have key vaults where we can have our secrets in the environment variables, and it helps to secure access. Another mistake we should avoid is not logging or monitoring open AI calls. We have the App Insight to help us monitor the health of our application. It would give us information about you know how the operation, how the application is performing, if users are having issues, if they're having challenges using the application. We have all of these logs when we have the App Insight. So it is important to work with the App Insight as well. Debug errors, improve prompts, track usage, and also detect abuse of that application. So, in summary, when we call the Azure Open AI, it is not a call or let me say, it's not a plug and play operation. It has to go through 7 solid layers before we get our response. And these layers has to do with the networking, security, governance, orchestration, compute, and safety before a response is returned to the end user. So this would be all from me today. Observations, additions, questions, the floor is open. Thank you, Frank, for this opportunity, and thanks to everyone who has joined my session.
Very good. Excellent. And yeah, you really explained like that it is complicated, all right, in the background. There's a lot of things to connect up. So yeah, you must have had some job trying to get it all working. So any questions? Anybody? Looks like you're all good. I gave a talk there last year. It was 45 minutes, and there was 85 people in the room. It was in person, and I had 15 minutes for the Q&A, and I got 25 questions. So
Wow.
you're off the hook.
Have you found the MCT environments helpful?
Very, very, very helpful.
Yeah.
Very helpful. That's why I want to make the summit, because there's quite a number of people I want to meet physically.
Yeah, that's true.
Yeah.
The summit last year was really fun. It was my first
Wow.
time meeting Solomon. I had a chance after the summit to meet Opiyemi Stephen at LinkedIn in London. It was just a really, really cool experience, all in all.
Wow.
Yeah, so they were kind of just gone over time, so I'm just going to end the live stream. So thanks everyone for being here. You can still stay on the call, anybody that's there. I just thanks for joining us, and we'll be back here again next week at the same time with the Azure and AI show. So any comments on any of the speakers, send it into our LinkedIn, and we'll be happy to get a response to you. Thank you.
Thank you, Frank.
Thanks, Harry.
Yeah.
Thanks.
Thank you. Thank you, Dan. Thank you, Frank. Thank you, Opeyemi. Thank you, Ari.
Thank